Shales and other tight rocks can be stimulated using two principal techniques: horizontal drilling and hydraulic fracturing. Horizontal drilling enables the well to penetrate a greater section of the reservoir than would be possible with a vertical well, increasing contact between the borehole and the formation.
Hydraulic fracturing, known as fracking, involves pumping water at high pressure into the reservoir to create fractures in the rock, increasing its permeability. Shale gas wells are typically 2 to 3 kilometers deep, with horizontal sections 1 to 2 kilometers long. A vertical hole is drilled to a depth below freshwater aquifers. Drilling mud pumped into the borehole cools and lubricates the bit and helps wash cuttings to the surface. This mud also coats the walls of the borehole, preventing mud from leaking into the surrounding rocks or water table.
The drill bit is removed, and a steel tube called surface casing is inserted into the hole and surrounded by cement. This permanently shields the aquifer from contamination by drilling fluids or produced gas. Vertical drilling continues until a few hundred meters above the reservoir.
Specialized equipment then begins to drill the horizontal section. This is called the kickoff point. Sensors in the drilling tool track the course of the borehole and may also gather information about the rocks being drilled through. Once the well reaches its target, the drill bit and drill pipes are removed. Steel production casing is fitted and cement is pumped into the space between the casing and the borehole, called the annulus. This fixes the casing and prevents unwanted leaks from the well.
With drilling finished and production casing in place, the well can be completed. This prepares the well for producing gas. A perforating gun attached to a cable is placed down the well, and an electrical signal triggers explosive charges, creating holes in the production casing and nearby parts of the shale formation.
The gun is then removed. The well is now ready for hydraulic fracturing or fracking.
Millions of liters of pressurized liquid is pumped down the well, causing the shale to fracture. Breaking up the rock in this way increases its permeability, allowing gas to flow through it.
Fracking fluid is made up almost entirely of water, but also contains some sand and small amounts of chemical additives. The sand acts as a proppant, keeping the fractures open after the fracking fluid stops being pumped into the hole. The other chemicals perform various functions, such as helping dissolve minerals in the shale, which can make fractures wider and longer. About 10 to 20 fractures are made by each frac. In short wells, one frac may be enough, but in longer wells, many frac stages occur, with plugs separating each stage.
The plugs are then drilled away, and gas can flow from the fractures into the well and to the surface, where it can be sold. Additional horizontal wells can be drilled from the same location in order to capture as much gas as possible from the shale. This reduces the economic cost and surface impact of the operation.